Hello. Right. I'll just open the chat and okay, perfect. So you should be able to hear me and see me. And let's get started. So today we're going to talk about geometric constructions and loci. Loci? Oh, I keep, I always get them wrong. Okay. Anyways, let's start with problem one. Probably before we start, in these questions, we tend to use only a straight edge and a compass. So when it says construct, that means we use a ruler with no numbers on it and a compass. Unfortunately, I don't have a compass, but I'm sure you understand how a compass looks like. Sort of like this, a bit of like a pair of scissors, but uh, serving a different function, of course. And so the basic things that you need to know how to do is the angle bisector. You should be able to do a perpendicular bisector. So the two basic constructions is the angle bisector, and the perpendicular bisector, bisector. And I hope you all know how to do these. So, for example, if you want a perpendicular bisector, you just take so AB is a given line, and you need a perpendicular bisector. So you draw a circle with center A, and you draw a circle with center B. You find where they meet, and your perpendicular bisector goes through these two lines. So this is the perpendicular bisector. The angle bisector, so if you have an arbitrary angle, A, and you want to bisect this angle. So you start by drawing a circle at center A, and then you draw two circles with center at these 2 points. So it goes like this, and like this. And the line joining these is your angle bisector. Angle bisector. Okay, excellent. So problem one. If AC is a line segment, use a straight edge and compass to construct a square ABCD. Note that we have A and C. In your assignment, you have a very similar problem, but you have AB. Okay, so we have A and C. And it is a line segment. So just like this. We need to construct a square ABCD. So B would be somewhere here, D would be somewhere here. So what do? Well, it's quite straightforward. We find the perpendicular bisector of AC. So first, draw perpendicular bisector of AC. By the way, when you answer the question, this is how you should answer the question. So solution. This is the model solution. Model solution. Okay, so we take a circle, as we have discussed. we take a circle center A, draw a circle center A, and we draw a circle center C with radius just over a half of the line AC. We find where the two meet, and we draw a straight line through. Apologies, I don't have the necessary tools. At least I couldn't find how to use them in order to be successful, in order to be accurate at this task. Okay. A perpendicular bisector of AC. Then, well, we know that this is a right angle, and this side is equal to this side. We know that the diagonals of a square intersect, and the point of intersection bisects them. So in effect, this side is also equal to this side. So all we now need is we draw a so let M is the midpoint. 2 is the midpoint. And 3, draw a circle, radius equal to AM, center at point M. And that means you draw a circle. I'm pretty sure Miro won't allow me to do this, but okay. Lovely. So these are new points. These are points B and D. And now join the lines okay. Almost. Draw a circle ABCD. So 4 B and D sections with the bisector, and then finally 5 ABCD is your square. Right? So this is a model solution of how you should format your answers to this in this assignment. Okay, so it should be clear what you're doing, each step laid out, not just a drawing. Okay. Hope that makes sense. And we move on to problem 2. Given 2 points A and D, use a straight edge and a compass to construct a regular hexagon. Okay, so we have A and D, so the 2 random points, A and D. Let's not draw them horizontal, so A and D. So somewhere here we can draw a hexagon, so A, B, C, D, E, F. Okay, lovely. So actually, AD is the diagonal of the hexagon, but it's also the diameter of the superscribed circle. Okay, so solution. So how are we going to do, how are we going to go about it? Well, obviously, the first thing you would do is to find the midpoint first. Draw a perpendicular bisector of AD. We don't need the full bisector, just a bit in a way. So AD. So you draw a circle around A. I think I have a solution to our problem. Now, if I draw a circle like this, and if I do a decent job putting A in the center, I can copy that and put it on D. Okay. And that's my bisector. Okay. I'm getting clever as we go along. Okay. Okay, so now I can delete these. Oh, not this. I can delete the circles. All right, now I draw AD. And that's my midpoint. Midpoint. 2M is the midpoint. Midpoint. Lovely. Midpoint is also the center of the circle. So 3, draw a circle, radius AM, a center at M. So we draw a circle around M. So let's use the circle tool. Should be about right. Okay. And now we do a clever thing. We want a hexagon. But a hexagon has an interesting property because these are equilateral triangles, right? So if this is the radius and this is the radius, this is also the radius. So we draw a circle of the same radius from point A. Draw a circle. 4. Draw a circle of same radius from point A. So we take this circle and we copy it. Like this. Where the circle meets, where the two circles meet, that's point B, B, C, D, E, F, and point F. B and F intersections, sections of two circles. And now we do the same. Draw a circle, center D. So we draw a circle center from D, and we get this point. And we get points C and E. C and E. Obtain C and E. And that's your hexagon. Okay? Well, I'm just going to do it. I'm just going to do it with a color. All right. Did you know how to do this question before I solved it? Yes or no? Did you know how to do this before I did it? Maybe not the same method. Maybe you thought. Okay, mostly. A longer way of doing it. Okay. Are in this way by using circles as compass arcs. Yes, it is fine if you use circles instead of compass arcs. Yes. All right, not a problem. Okay, well, yes, I'm sure you would have figured it out, and it's, yeah. Problem 3. Using a straight edge and compass, construct a triangle ABC with side AB, which is given below. Angle A is 30 and B is 45. Interesting. So, actually, you know what? We actually need to do question 4 first, and then we can do question 3. Okay. Question 2. Construct an angle which is equal to a given angle. Right. So we have an angle. We need to draw another one. We need to make a copy. How do we do that? Well, of course, I can make a copy, but okay. An angle which is given equal to a given angle. It's not that hard, and all you need to do is draw a circle with center at the center here. So first draw. So this is a draw circle, center A. The radius does not matter. And then you take, then on the, so this side is going to be the copy. This is going to be a copy of our angle. And let's call it, well, let's call it M. Draw the same, draw same circle, center M. So we take this and we draw. We can do that because we can do this because we can use our compass to draw two identical circles, right? We just don't change the settings. And then we take our compass and we measure with the compass. We put the compass at point B and C to measure BC with the compass. Draw circle M N, center N, a radius BC. So we just take the compass, we put it like this, yeah, the compass thing. And then we move it to point N, and we get the same radius. So we draw a circle. We draw a circle around N. So basically, what we're doing is we're saying, look, I want to take a circle, center B, and I want to copy it around. Oop. Not that great. I want to copy it from point N, and that's my point MNP. And then this is the angle, and these angles should be the same. Okay, obtain. So 3P is the intersection of two circles, and their angle PMN is equal to angle CAB. That's what we needed. Now, go back to problem 3. So effectively, we need to draw an angle of 30 degrees and draw it from point A. Okay, how do you draw an angle of 30 degrees? Well, different ways of doing it. I think the easiest way is to draw an angle of 60 degrees first, and then bisect this angle. And drawing an angle of 60 degrees is really easy. So let's say we have a 60-degree angle. So we draw a circle with center A, going through B, and then we draw a circle with center B going through A. And where they intersect, that's C, and this would be a regular triangle or a equilateral triangle. That's a 60-degree angle. And then you just bisect this angle. So you draw a circle from B and from C, and then you draw a bisect, and that's your 30-degree angle. Okay, so I'll try to be neat here. So choose a point, and let's call it point D. Choose a random point D. Draw a circle center A and circle center D. The radius of the circle, is AD. Okay, so Does this sound right? Nope. Okay. Copy it. Draw a circle, center D. And that's your point E. So triangle A, well, angle EAD is 60 degrees. Bisect this angle, 3. Bisect angle EAD. So how do we bisect an angle? Well, we know how to do that. So we draw from D, we draw, well, all we need to draw is to draw another circle from, draw a circle, center E. So we already have the circle. So all we need to draw it is here. And where E and D meet, that's point, let's call it F, angle FAD, angle FAD is 30 degrees. Ta-da! So we draw ray AF. Draw ray AF. Okay, so we've done the 30-degree angle. Now we need the 45-degree angle. To do the 45-degree angle, we will use a right-angled isosceles triangle. So right-angle isosceles triangle. So it's a 45, 45, 90. 45, 45, 90 triangle. So how will we do that? Well, actually quite straightforward. Draw a perpendicular, so choose a point, so that's going to be 5. Let's change color. 5. Choose a random point. M. Okay. 6. Draw a perpendicular bisector. Of MB. Okay, so we know how to do this. So you don't have to explain every single time. You don't need to explain how you do a perpendicular bisector. Okay, so just saying draw a perpendicular bisector is fine. And so draw 2 circles. Draw a straight line going through the 2 lines. Okay, so you can delete the construction circles if you are actually right perpendicular, and then find the midpoint. Let's call it N7. N is the midpoint. 8. Draw circle, radius NB. center N. And that it will be like this. And oop. Yep. And MNP 9 draw ray BP. BP is a ray, and that's your triangle. Where the two rays meet, that is C, and that is your triangle, which we've done purely by construction. So this is A, B, C. Okay, lovely. And so we've done problem 4. So you know how to make copies of angles. So you could have done separately. You can have done the 30-degree angle separately and the 40-degree and the 45-degree angle separately, and then just made copies of that angle. So that's another way of doing it. All right, problem 5. That's sort of an interesting one. Here, you're not allowed to use straight edge or a compass. Okay. I'm going to draw. Well, of course, I can use a straight edge to draw them. So like this. So this is an angle. Right? They meet somewhere here. Right. You need to construct the bisector of this angle, but you're not allowed to use anything. One would even argue you don't need a pen. How on earth would you do that? Can somebody help me? Fold it how? Fold it along the lines. What would that do? You know what? You might be onto something. Ooh, James has an idea. So the lines are on top of each other. Yes, Ben, you can actually, yes, you can fold them along the lines. You don't have a compass, you don't have a straight edge. So you can't draw circles. You can fold them along these lines, yes. And then you would get a piece of paper and then you just fold it in half. Yeah, that works. Actually, James, yes, your suggestion is almost the same. It's so you fold them in a way such that they align perfectly. So I have to see it for myself. So the two lines should line up perfectly like this. Okay. Oh, sorry. Yeah. So the one line, two lines, and when you line them up, it should be a single line. Yes. Okay. And that is how you get your bisector. Okay. I will, you know what? Am I still sharing my screen? Oh, yes, I think I am. Okay. How do I? Okay. Right. So yes, that's how you do it. Quite a nice one. Or you can fold them along these lines. You can do it like this. Okay. And then just fold it along this line so that they match. So it's the same idea effectively. You just want them to line up, the two lines to line up, and that's your bisector. While we're talking about pieces of paper, I've got some homework for you, of course. So the homework goes like this. Take a post-it note or something similar in size. It doesn't have to be a post-it note. Okay, post-it notes are ridiculously expensive for what they are. So just take a small piece of paper. And I want you to cut a hole in this piece of paper. And you should be able to climb through that hole physically. Okay? That's your first cut a hole in a post-it. So homework. Cut a hole in a post-it note so that you can climb through it. And secondly, the second part is an extension task. Extension task. Cut a hole so that a very well-behaved elephant can climb through it. Extension and elephant can climb through. Okay. Does anyone know how to do it? Well, I'm guessing there is a limit. There is a size limit. Because let's say a post-it note is 10 centimeters by 10 centimeters. 10 centimeters. So it's 0.01 square meters. if you have a ring made of paper, so a hole, right? A hole is in paper. So the width of this paper cannot be less than the width of an atom. So I'm guessing part 3. Yeah, Ben, you're onto something. And James, yes. The size of an atom is 10 to the minus 10 meters. That's the size of an atom. So the circumference, the maximum circumference that you can have, if it's the width of an atom, of course that wouldn't hold, but let's imagine for now the width of one atom. So it would be the area divided by the width. So the area is 0.01 meter divided by 10 to the minus 10, which would be 10 million meters. That's a lot. That's about 2,500 times around the planet Earth. So yeah, you would probably fit Jupiter in. You can fit Jupiter. You, if you can slice paper to the width of an atom, you could fit Jupiter in. Oh no, sorry. Sorry, 10 million meters. That's only 10,000 kilometers. No. You wouldn't be able to fit the Earth in. I'm very sorry. That's you would probably the moon, just the moon, no Jupiter. Kilometers, probably fit the moon. Anyways, yeah, that's homework. Problem 6. I really like this one. So you have a river and you want to build a bridge. You want to build a bridge. The bridge is perpendicular to the river. Okay, because it's very expensive to build a bridge. But you want the path from A to B is the shortest possible, well, including the bridge, of course. Okay, so of course, if you build a bridge here, you would have to walk like this and then walk like this. So probably that's longer than walking like this, building a bridge, and then walking like this. So there is an optimal path. So the idea is that going from A to B should be the shortest possible path. So it should be a straight line. Of course, you can't go straight because the bridge has to be perpendicular to the river. So let's draw the bridge. Let's draw the bridge. And how are we going to draw the bridge? Well, that's the bridge. So if you imagine walking from A to B, you inevitably will have to go along this line. Why not do it like imagine doing it from the very beginning? So immediately from A, you go down. So as if you crossed the bridge. The remaining path has to be a straight line. Okay. So the method. Draw. So M, N, A, C. Draw AC, which is parallel to MN, and AC is equal to MN, right? To draw CB. Where CB crosses the river the second time, that's where you should your bridge should be. So, oh, no. So you copy your bridge and you place it here. That's the position of your bridge. And then you just draw the line from A to let's call it D. D. And this is E. All right, so you walk from A to D, from D to E, and from E to B. And as you can see, because CEB is a straight line, then AD is parallel to 3. AD is parallel to EB. Therefore, the path AD plus EB is the shortest possible. Yeah, because the total path from A to D, and D to B, and well, E to B should be the shortest possible. And the shortest possible is when AB is a straight line. So that's where you, by construction, we have built the bridge. So DE or DE is the position of your bridge. Okay. And final problem 7. Ooh, we've done very, very quickly. We'll probably finish at 7. Given 2 points A and C, use straight edge and compass to construct a regular hexagon. So this is the same problem as problem 2, was it? Yeah, problem 2, except now A and C are not the diameter and they're not adjacent points either. So you got A, B, C. So you got these 2 points. You got these 2 points, and what you need is to find the whole hexagon. Wow, I just realized one thing. And this problem is not as difficult as I thought initially. Okay, there are many solutions. I'm gonna show you. I'm gonna show you probably 2 solutions that I have come up with. I'm sure there are more. So let's say this is AC. It is just a random 2 points. And we're doing construction, right? So, well, okay, so let's do my first solution. And then I'll show you the second solution, which I just came up with like 2 minutes ago. First method. I draw a line AC, and I need to draw an angle of 30 degrees. 30 degrees to AB. But I already know how to draw a 30-degree angle. Remember, I take a random circle and I mix some copies. So that's circle, 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 and that's my 30-degree angle. Okay. And then I do the same. Do I have to do the same? Well, yeah, I can either do perpendicular bisector of AC, or I can just do, yeah, I'll probably need the perpendicular bisector. Yeah. Draw a perpendicular bisector of AC, so I'll need a bigger circle. Ideally, a circle with the same size as AC. Okay. Method first, draw ray AF. Oh no, we have F. AM, where angle MAC is 30 degrees. Okay, so this is MAC. It's a 30-degree angle. Second, draw perpendicular bisector of AC. And to do this, we draw, we take two circles. Okay, so I copy this circle. We draw a circle. Oh, no, it has to be bigger. That big enough? Oh, yes. And then we draw a perpendicular bisector of AC. And where the perpendicular, where the bisector meets AM, that's point B. Point B. Okay, so we found point B. We can delete this. We can delete the circles. They're really annoying. Bum, bum. Okay, so now we have BC. BC. And now we can draw a circle center A. For draw circle center A, radius AB. So that will look like this. Okay, and where it meets the bisector, that's point O, and we're almost done. Point O, and then just draw a circle. 5, draw circle center O, and Oop. Same radius. Draw circle center O, and then you draw another circle center C. You draw another circle center D. Oh, you don't need that. Oh, yeah. Circle center O, circle center O, circle center C. That gives you point D, equal to point D. And then where it meets this circle, that's E, that's F, and that's E. And that's your hexagon. Bam, bam, bam. So you're gonna you have to be creative here, right? Just, yeah. The second method that I've just came up with, so second method. I actually forgot it. Okay, let me see. So you have, oh yes, of course. So you have A and C. A and C. So, well, if you think about it, if you have a hexagon, this is A, this is C, this point is DE. E. ACE is an equilateral triangle. ACE is equilateral. Equilateral. So you can, and you know how to draw equilateral triangles because we've already done it. Okay, so you draw a circle center A, circle center C, and that's your point E. And that is E. So first, AC equilateral, 2, find E. Find E by drawing circles. And then, so we have we have an equilateral triangle, ACE. Now we can find the perpendicular bisector of, yeah, find the perpendicular bisector of AC. 2, 3. So find bisector perpendicular bisector of AC. So we can, so it's a line going through the center and going through the point E. I'm just going to be a bit lazy here. And you can find the perpendicular bisector of CE. 4. Find perpendicular bisector of CE. So CE is this, and perpendicular bisector is like this. So where they meet, that's the center of the circle. 5 bisectors meet at O, which is the center of the circle, of the center of the superscribed circle. So you found point O, and once you've done that, everything else just falls into place. Draw a circle, center O. Draw a circle, center O. It's going to be smaller than that. Okay. And so you have A, C, and E. Then you just draw a circle of center A to find this point. Oh, this point was you already have. And then you just need to find two more points. Oh, you have this point, and then you draw a circle around E to find this point. And then you have the hexagon. Hexagons are really fun. I mean, as shapes go, hexagon is one of them. Can you draw the triangle and then find the other point? Can you draw a equilateral triangle ACE? Oh yeah, that's what it did. Yes, perfect. Okay, then bisectors meet at center 6. Draw circle center O. 7. Find B. Find B, D, E, F by drawing circle